Hello, my fellow students. I know that you guys are excited to take a new shift in our curriculum to geometry. So we are now shifting from a bunch of different algebra stuff to now geometry, which we need to talk about some review information found in geometry in order for us to do the actual things we need to do in geometry. So hopefully this will be a review, and if it's not, well, hopefully you learn some of these new concepts. Alright, so we're going to start with our basics on angles. Okay, which an angle is something that is created by two nifty things called a ray. Okay, so it's an angle created by two rays with the same endpoint. So a ray is something that has an endpoint and then extends in one direction for forever and must cross through at least one more point. So looking here, okay, this is an angle created by ray BA. So ray B, or ray BA, starts at point B, this is its start point, and then it heads off in this direction for forever and crosses through point A. Okay, so we call this ray BA. And this little symbol above here, it kind of looks like what a ray looks like. This means ray BA. So in geometry, we have lots of different little symbols we put above letters that mean different things. So if you see something that looks like this, so it has only one arrow on it, it means ray. Okay, and the first letter you always see in a ray is its start point. Okay, this is not ray AB. Okay, A to B would look different. It would have an endpoint here and have a line extending through B. Okay, so be careful. Ray BA is not the same thing as ray AB. So be careful. The angle is created by ray B to A as well as ray B to C. So both of the rays start at the same endpoint B, and extend in one direction through another point. Okay, so that is what an angle actually is, if you didn't know. Now, the symbol we use to denote an angle is this right here. It kind of looks like the shape of an angle, or it kind of looks like a greater than symbol, but it's not a greater than symbol. In geometry, it actually means angle. So in geometry, there's lots of little shortcuts to write out things because mathematicians are lazy, and instead of saying angle, whatever, we can use symbols to denote the word, so we don't have to write out the word. So it's actually kind of clever, but yes, mathematicians are really lazy, and in geometry, there's lots of symbols, so we don't have to write out the whole word. Like here, I don't have to actually write ray BA because the symbol means ray. So technically, I could have left off the word ray, and this would have meant ray BA. So yeah. Alright, now, all angles have vertex points, which vertex point is the point on the angle where the two rays meet. Okay, so it's that common endpoint that the rays share. So in my picture, the vertex point is called B. So it's kind of like the little point at it's like the little point that's located at the tip of the angle, or the pointy part of the angle. That's how I like to think about it. So that is what an angle is. Let's keep going. Now, there are very specific ways to name an angle, and we have to be careful of the way we name an angle because people won't know what you're talking about if you name an angle incorrectly. So, let's look at this angle that we had in our previous picture and talk about all the lovely ways to name this angle. So, way number one, you start with a point on one ray. Okay, so you pick a ray, it doesn't matter, you pick one point on the ray. Then you list the vertex point, and then you list a point found on the other ray. So you kind of like trace the angle as you name points. You pick a ray, pick a point, go to the vertex point, and then go to the other ray and pick a point. So this one, we can name it ray A, B, C, or it's the same thing as C, B, A. Now be careful, this is not the same thing as angle A, C, B. Okay, be careful. Okay, I have to start at a point on the ray, then directly go to the vertex. So that middle letter in both of my angles is always the vertex point. It always is. Okay, it cannot be a point on the ray, so be careful. Alright, the second way to name an angle is by listing a number found inside of the angle, if there is one. There's not always a number inside the angle though, so be careful. So like in this angle, there's a little 1 kind of hanging out in the middle of the angle, so I could call this angle 1. Remember, this is our symbol we use to say angle, so angle ABC, angle CBA, and angle 1. Now there's a third way I can name this angle as well. Okay, I can also call it by its vertex point, but only if no other angles share a common vertex point. Okay, so if there's an angle all by itself and no other angles start at the vertex, okay, then you can name it by its vertex point. So this is also angle B. So this angle has lots of different ways to name it, which is pretty cool. Okay, now this is the reason why we don't name angles by their vertex point if there's more than one angle. Okay, let's say I have this picture of this angle right here, which actually there's several angles in this picture. And let's say I want to call one of the angles angle B. Well, what angle am I talking about? Am I talking about the big red angle? Am I talking about this angle right here that starts with the red and goes to the blue ray? Or am I talking about the angle down here that starts with the blue ray and goes to the red ray? Okay, do you guys see how this is very non-specific? So we can only name an angle by its vertex point if it's all by itself. Because technically this angle is three angles, and if I call an angle B, I don't know what you're talking about. Okay, I don't know if you're talking about any of these angles. So this picture technically has three angles. It has angle ABC, so the big angle, which you can also reverse it and call it CBA. It has this little angle up here, which is ABD, or you can reverse that thing to DBA. Or it has this one down here, so DBC or CBD. Okay, so again, you cannot name an angle by its vertex if there's more than one angle attached to the vertex. So be careful. Let's keep going. Alright, so we're going to name all the different ways to name the angles in this picture. So it says name all of the angles that you see in this picture in as many ways as you can. So all these angles have special names and they do have more than one name. So it's kind of cool. So let's start with this big orange angle. Using those three properties we talked about from before, what could be one way we name it? Well, we could start with the points, which these letters all denote points, okay? Even though there's not like a point drawn in. If you guys ever see a big letter, that is representing a point. Alright, so you could start with the point, go to the vertex, and go to another point, or reverse it. So I could call it angle ABC or CBA. I can't call it angle B, though. Be careful, because the vertex point is shared with multiple angles. So my first angle is angle A to the B to the C, or C to the B to the A. And again, that middle letter is always your vertex. So be careful. Alright, now let's move on to this top angle that I've colored in blue. So again, we could start with the point, go to the vertex, and go to a point on the other ray. So angle ABM or MBA. Okay, or I could name it by the number or letter that is written inside. So I could also name it angle X. So those are my options for my second angle. Alright, and my final angle. Again, I could start with a point on one ray, shift to the vertex and go to the other point, or I can name it by the letter inside it. So I can name this angle MBC, angle CBM, or I can name it by the cute little Y on the inside, so angle Y. So those are the ways to name all three of the angles found in the picture. Pretty cool, right? It's kind of like the name's got like, or the angle has like several different names that represent it, which is kind of cool. Alright, now let's talk about special types of angle pairings. Okay, so our first type of angle pairing we're going to talk about is something called complementary angle. Complementary angle. So what is a complementary angle? Well, a complementary angle are two angles who have measures that have a sum of 90 degrees. So when you put these two angles together, they have to add up to be 90. Okay, so in my picture, these are two angles that add up to be 90. Angle B and angle A, when you put them together, make this nifty right angle here. So right angle is another way to say 90-degree angle. And this little box thing you guys see inside the angle means that it's 90 degrees, or a right angle. Okay, now, if you do not see this little boxy thing, you can never, ever, ever assume that an angle is a right angle without the box, unless there's another way to get there. But if you just see an angle that looks like a right angle, but it does not have the little boxy, be careful. It might not be a right angle. Okay, you can never, ever, ever assume things in geometry. Okay, so bad things happen to people that assume things in geometry. You cannot assume things unless you are given information. So if something looks like a 90-degree angle, it might be like 89.999. Okay, so be careful. If you don't see a little box, you cannot assume it's 90 degrees. So angle A and B are complementary, and they add up to be 90 degrees. Now this little M thing, what this means is the measure of angle A plus the measure of angle B equals 90 degrees. We use the little M thing when we're talking about the measure of an angle or when we're talking about the degree of an angle. So when you add up the degree of angle A to angle B, you get 90 degrees. Okay, without the M, it's just specifying the angle. So this is angle A, and that's angle B. So be careful. The M is very important. When you're talking about an actual angle measure, that's when we put the M. Now, supplementary angles is another nifty kind of angle pair that we're going to talk about. It's kind of like complementary angles, but slightly different. So supplementary angles are two angles whose measure have a sum of 180 degrees. Okay, so these two angles right here add up to be 180 because they form a line. And how many degrees are on a line? A line is 180 degrees, which is pretty cool. Okay, so when you add up the measure of angle A to the measure of angle B, you get 180 degrees. And angle A and B are supplementary. Another nifty angle pair, they are called vertical angles. Okay, so vertical angles are two angles that are formed by two lines. So usually they're kind of spotted at X's. Do you see how these two lines form an X? Okay, so vertical angles, you have to spot the X before you see vertical angles. And vertical angles occur when two lines intersect and make that X shape and are across from each other. So, like here, so two angles created by intersecting lines that are across from each other. So angle 1 and 3 are vertical angles, as well as 2 and 4. Now, there is an interesting property about vertical angles. Okay, vertical angles are congruent. And congruent means they have the same measure. So when we talk about angles, if I say that angles are congruent, that means that the angles have the same measure. If I say that segments are congruent, that means the segments have the same length. So be careful. So vertical angles are congruent. So what that means is angle 1 is congruent to angle 3. That weird symbol in the middle with an equal sign, a little tilde thing on top, that means congruent. Okay, so angle 1 and angle 3 are congruent. And the way we show that angles are congruent, in geometry, you're going to be marking your picture like all the time. And the way that we show these are congruent are by drawing little arcs within the angles. And we have to draw the same amount of arcs to each angle that's congruent. So like, see, angle 1, I drew like two little arcs on the inside of angle 1. So the angle that's congruent to it must have the same amount of arcs. So this one has two arcs as well. So that shows me that angle 1 is congruent to angle 3 in my picture. I can also say that angle 2 is congruent to angle 4. And I have to use a different amount of arcs to differentiate it from angle 1 and 3. So angle 2 is congruent to angle 4. So in your picture, you mark that these angles are congruent with these little arc things and using the same amount of arcs. Pretty cool, right? Let's keep going. Another type of awesome angle pair are called adjacent angles. Now, what does the word adjacent mean? You guys are so smart. Adjacent means next to. So adjacent angles are two angles that are right next to each other. In the formal definition, two angles that share a common vertex, so they must have the same vertex and they must share a common side of the angle. So one of the sides of the angles must be the same, and this part is super, super important, you guys. They do not share any common interior points. So they're two angles that are side by side, and if you look at all the points on the inside of the angles, none of them are in common. So like, for example, CAB and BAD, angle bad. I like to name my angles fun things. So angles CAB and BAD are adjacent angles because they both share vertex A, they're both right next to each other, and they don't share any interior points. So here's angle CAB, and I've kind of shaded in the angle so you can see the interior points of the angle. Here is angle BAD or BAD. Do you guys see how none of the interior points intersect? They're kind of separated. So that's how I know they're adjacent angles. So they share a vertex point, and they're right next to each other, and they share a side, which they share side AB. Okay, ray AB is the ray they actually share. All right, now, our angle CAD, so it's the big angle and CAB, this green one, are they adjacent? Well, they share a common vertex point. They both have a vertex point of A, but do they share any common interior points? Well, let me shade in angle CAD. So this is angle CAD, and I've shaded it in. Do my green and orange angle overlap at any point? Holy hot dog, they do, right in here. Okay, so these are not adjacent angles because they share interior points. Right here is where they have points in common. So you guys have to be careful. Adjacent angles, although they do share a common vertex point, cannot share any common interior points. So be careful. Alright, so our angle pairs. Our next one is called a linear pair. So, this is kind of like supplementary angles, but there's a catch. So, a linear pair, first of all, they have to be two adjacent angles. Supplementary angles don't necessarily have to be adjacent, so be careful. So they have to be right next to each other, and they have to form a straight line when you put them together. Okay, and since they form a line, it makes them supplementary, which is cool. So linear pairs kind of form, or they kind of combine the properties of adjacent angles and supplementary angles into one, which is pretty cool. So angle A and angle B form a linear pair and are supplementary because they add up to be 180. So the measure of angle A plus the measure of angle B equals 180 because they form line L, which a line makes 180 degrees. Pretty cool, right? Alright, now example 2 is going to be super fun. We're going to use all these angle pairs we talked about to name all kinds of angle pairs we see in the picture. So in example 2, we will be identifying all the adjacent, complementary, supplementary, and vertical angles in the picture. And we're going to name as many as we can see, which some of them have a lot, so we're going to restrict how many we label. So go ahead and pause the video and watch example 2 on how we label and identify all these different angle pairs. Alright, now, example 3 and 4. We're going to be combining properties of all these angle pairs we talked about to solve. So example 3, we're going to reference this picture and solve for x and the angle measure containing the x. So we're going to be solving for this angle right here, which is pretty cool. Okay, in example 4, we will be using this scenario to solve. So it says two angles are supplementary if one angle measures 2x plus 18 and the other angle measures 3x minus 3, find the value of x in each angle. So we'll be using properties of supplementary angles to find the value of x in each angle. So go ahead and pause this video and watch example videos 3 and 4. Holy hot dog, you guys. We have another example to do. So this one, again, we're using our properties of the different angle pairs we talked about to solve for the different values of x and y and to find the value of angles. So we're going to be combining kind of all the angle pairs we talked about, which is pretty awesome if you ask me. So go ahead and pause the video and watch example 5. Alright, now the next amazing topic we're going to talk about is something called a midpoint. Okay, and this is just the midpoint of a segment, just kind of in space. We will talk about midpoints in a coordinate plane, which is slightly different. Alright, so a midpoint. What does midpoint kind of sound like? Holy hot dog. I don't even know why I guys ask you these questions. You already know. A midpoint kind of sounds like the word middle. And guess what? A midpoint is a point that lies in the middle of a segment. Okay, so the definition, a point that lies in the middle of a segment and divides the segment into two congruent segments. So since the point is in the very middle, it splits the segment up into two segments that are congruent. Now, a segment, you guys, is different from a line, so be careful. A segment has a start and an end point. A line extends in two directions for forever, so be careful. Okay, so the way we call something a segment, do you guys see this line kind of above AB? And it does not have arrows. If you see arrows on both sides, it's a line. It means line AB. If you see an arrow on one side, that means ray, so ray AB. If you don't see any arrows, it's a segment. Okay, so segment AB starts at point A and ends at point B. We have another segment, segment AM. It starts at point A and ends at M. And we have a third segment in this picture, segment MB. It starts at point M and ends at point B. Okay, and according to this definition, it divides the segment into two congruent segments. So if M is my midpoint, okay, it means that the two segments that are in between that midpoint are congruent. So segment AM is congruent to segment MB. Remember, that's our nifty congruent symbol, the little equal sign with the little tilde. Okay, and the way that we make marks for congruent segments are with these little dashes. This means that segment AM is congruent to segment MB. So in our picture, if you draw the little dashes, that means they're congruent. And like with angles, you have to make the same amount of little dashes to say they're congruent. So if this one had like 2 dashes and this one only had 1, they're not congruent because they don't have the same amount of dashes. So you have to make the same amount of little marks in order for it to be congruent. So be careful. On segments, we make little like tick mark things to denote congruency. With angles, so if I go back to the angle slide, the angles, we use these little arcs to mark congruency. So be careful. Angles, we make pretty little arcs that go through the angle. Segments, we use little tick marks. Okay, so be careful. There is a difference. All right, now, there is a midpoint theorem, or if you have a southern twang, you can say therm. That's kind of fun. The midpoint therm states that there's several things it states, actually. This says that AB, so guys, do you see here that it does not have a line above it? What's going on? So these all have lines above it, or segment AM, segment MB, okay? If you see two letters without a nifty little line or segment or ray or anything above it, that means the measure of AB. So that's talking about the actual length of the segment. Okay, when we use congruent symbols, okay, that is talking about an actual object, and they have the same length, but we're not talking about length. We're talking about the actual object in space. So the object, the segment AM, has the same length as segment MB, but we're not relating, or we're not specifically talking about the length. If we're talking about the actual length of the line, we leave off the little symbol above it. So this means the length of AB is equal to 2 times the length of AM. So AB is the whole segment. If we double the piece that starts at the end and goes to the midpoint, since this is where the midpoint is, if we double this piece, it equals the length of the entire segment. Same if we use the other midpoint segment. So segment AB is also equal to the other segment that starts at an endpoint and goes to the midpoint. If we double that, we get to the entire segment. So that's one way to look at it. The other way is if we reverse it. So if we start with one of the little segments, okay, the segment that starts at A and goes to M, so starts at the end point and goes to the midpoint. If we, in order to get the length of this segment, we'd have to half the length of the entire segment. Same with the other one. This length right here, if you take the entire segment and half it, you should get this length. So there's 2 different ways to kind of look at that, which is kind of cool. Alright, so example 6 and 7 will be using those properties of midpoints and the midpoint theorem, or the way I like to say it, midpoint therm. Okay, we'll be using the properties of the midpoint theorem to solve things about midpoints. So go ahead and pause the video and watch examples 6 and 7. Alright, so now we are talking about a midpoint formula, which this is what we use when we're finding midpoints on a graph, so in the coordinate plane. So we have to have actual points, like with an X and a Y, to use this formula. So if we are given 2 points, the first point we're going to say x1, y1, sorry. The second point we're going to use x2, y2. Okay, if we have these 2 points hanging out somewhere in the coordinate grid, the way that we find the point in the middle of this segment is adding the x's together, so x1 plus x2, and dividing that bad boy by 2. That is your x-coordinate of the midpoint, and the y-coordinate of the midpoint, if you add the 2 y points, or the 2 y-coordinates in each point, and divide by 2, you'll get the y-coordinate of the midpoint, which is pretty cool. And the reason why this works out, you guys, the midpoint is in the middle. Okay, and another way to find things in the middle is by taking the average. Okay, so basically this midpoint is created by finding the average of the x values and finding the average of the y values. So that might help you to remember the formula. Okay, and again, this formula gives you the point that is halfway in between 2 points found on a coordinate grid. Okay, we cannot use this scenario looking back here because this isn't really in a coordinate grid. It's just kind of a segment that's in space somewhere and it doesn't have an x and y coordinate, so be careful. Okay, so this is a little different. Alright, so if you go ahead and pause the video to watch example 8, you will find out how we can use the midpoint formula to find the midpoint in between 2 points in a coordinate grid. So go ahead and pause the video and watch example 8. Alright guys, the last thing we're going to talk about in this lovely PowerPoint is something called the distance formula. Alright, and again, we are working in the coordinate grid, so we have to be like on a graph. There's got to be an x and y axis. We've got to have some x and y coordinates, okay? If you are in the coordinate grid, the way that we find the distance in between 2 points on the x and y axis or in our coordinate grid, okay, is by using this formula. So if we have 2 points, our first point, again, is called x1, y1, and our point 2 is called x2, y2, we use this nifty formula and bam, you'll know the distance between this point and that point. So you start by subtracting your x2 minus your x1 and squaring that thing. Then you're going to add that to your y2 minus your y1, and you're going to square that. And when you add those together and square root that thing, bam, you have the distance in between one point to the other point. Okay, and again, it allows you to find the distance between 2 points in the coordinate grid or on a graph. Okay, be careful. This is not finding the distance of just some random segment that's not on a graph, so be careful. Alright, so example 9 and 10 are our final example questions in this section, and you will learn how to find the distance in between 2 nifty points in the coordinate plane. So go ahead and pause the video and watch example 9 and 10. Oh no, you guys, that's all. I'm sad it's over, right? I don't want it to be over. Sorry.